Uh, Hello everyone. So today I'll be explaining the concept of generating functions. Basically I would like to first explain what is generating functions. So generating functions is basically a way to encode a sequence of numbers into algebraic expression. What is generating function? Generating function is a way to encode a sequence of numbers into a single expression, that is a power series, usually in variable x. Okay, what is what is the main application, like where can we use generating functions is as you can see here the example, like the sequence is 1 plus x square, x plus x square up to x raised to n, right? So what will be the sum of this series? The sum of this series will be 1 minus x raised to n plus 1 upon 1 minus x, right? So you all might be well known with the concept of geometric progression, right? So in geometric progression what happens is we were be provided with the geometric series, and we were finding the r and doing all the calculations like sum to infinity and all that, right? So the similar sequence is here there, but we will be using generating functions here to solve the more complex problems using using the magic of mathematics, turning them into turning the complex problem, the combinatorics problem, counting problems into the algebraic, the polynomial problems, right? So and those will be easily solvable. Okay, so here are some variations of the series I showed earlier. So it is like as you can see here, the 1 plus x, 1 plus ax plus a square x square, a cube x cube, right? So to solve this series, to get the sum of the series, we have got a formula, right? So 1 upon 1 minus ax. In see, like using generating functions, the use of generating functions we find right in the combinatorics problem. Like best example is in combinatorics problem, like see, a dice is thrown 5 times and we need to find the number of ways we can get sum 20, right? So doing with the basic uh, counting method, it would take some long time, right? So using generating functions, it makes it a little easier solving it. Okay, so I would like to show the example of rolling a dice. As you can see, rolling a dice 5 times, rolling a dice 5 times and getting sum 20. So yeah, getting sum 20. So yeah, as you can see here, what I have done, simply we will be finding the coefficient of x raised to 20. Okay, so basically first let me explain the expression that I have written over here. See, this is basically 1 x raised to 1 till x raised to 6. These are basically the possibilities of rolling a die. X raised to it will be 1 to 6, right? So it's these are the simply possibilities, and we are rolling the dice 5 times, so its power raised to 5. Its power is 5. Okay, so now further solving, we will be finding the coefficient of x raised to 20. So what we will be doing here, first of all, to simplify the expression, to bring it into the generating function format, what we have done here is taking common x. So it will be x raised to 5 will be factored out, right? So when earlier we were finding the coefficient of x raised to 20 in this entire expression, now we will be finding the coefficient of x raised to 15 only in this expression, right? So finding coefficient is simple. Okay, so what we will be doing is to find coefficient, we will be using the formula which I showed earlier. which was the yeah, this one. Yeah, we will be using the formula, this formula, to find the coefficients of the numbers. Okay, to find the coefficient of x, sorry, not numbers, to find the coefficient of x, x power. So expanding this, what we'll be basically doing first is we will expand, we will use binomial distribution for this numerator. We will get this, and from this we need to extract only those values, those terms which are beneficial for us, right? So which will be beneficial, right? We want the coefficient of x raised to 15, right? So for x raised to 15, we can get x raised to 15 from 5c0, 5c1 x raised to 6, and 5c2 x raised to 12, right? When we are going further in x raised to 18, it's already above 15, so we will not consider. We will consider only these three terms. Consider those three terms, and we'll use the formula on 1 upon 1 minus x whole raised to 5. So now we have got the terms of our intent, that is the for that is useful for finding the coefficient of x raised to 15. Yeah, then the further method is very simple. We need to just consider the how we can get the terms x raised to 15 over here, right? So here it's x raised to 0. So to get here x raised to 15, we need to simply put here value 15, k equals to 15, n equals to, we have already 5, right? So by putting x raised to, we get the coefficient of x raised to 15 as the total term, that is 9c15. Okay, here it's already present x raised to 6, so we need more x raised to 9. So we'll be finding for c9, right? So for k equals to 9, we will be getting 13c9. Okay, then further we already have here x raised to 12, then we need more for 15, we need more x raised to 3, right? So we'll be finding for x raised to 3, so that is for k equals to 3. Yeah, and that's a further simple calculation. 5 into the enter, and enter calculation, and the number of ways we can get this sum equals 20 is 651. So yeah, follow for more. If you need some more content on the generating functions or any other else, just comment down below.